All right. Um, Ruben, I know it's hella late for you. Do you want to go first? I'm excited to hear about it.
Please. Yeah. Yeah, let me share my screen. It's a little complicated, but we can talk through all of this. Hold on.
Yes, please make copious
Um,
time for questions because I'm sure we're gonna have a ton of them.
yeah, there's quite a bit. Okay, can you guys see this beautiful kind of ridiculous sequence diagram?
Oh, good God.
Yes.
Yeah,
Okay.
okay. It's ridiculous, but it is what it is. Okay. So, okay, actually, let me first things, let's go to the issue itself.
I have no
Can you
idea
zoom
what that
into
is.
the diagram a little bit?
Yeah, give me a second. Oops, wrong thing, wrong thing. Yeah, so let's see. Can I zoom in? I must be able to. Oh, yeah, sweet. Let's see, how can I do better here? Can I turn off this part? I just want the rendering. Okay. No, no. Oh, did that help? That helped, actually. Yeah,
Yeah, this is great.
great. Okay. Yeah, so yeah, we've been doing a lot of work trying to figure out how to get these metrics running continuously. So this has kind of gone through a bunch of evolutions, which I have now detailed in some detail, at least in this 2471 issue. Ray, we can talk about this later, but basically this was my attempt at making like this is a meta issue, like it's more of an epic kind of describing the general goal for a bunch of different smaller sets of issues. um and then yeah, there's also some other thing. We can't add new stuff to projects. We're out of whatever quota. But yeah, sorry, that's neither here nor there. But basically, yeah, what we've kind of gone through here. um so what we've been doing, right, to figure this out, is working through kind of a bunch of assumptions about how to make all of this work. So originally, when we got this, we actually wanted to make um we wanted to run all of this on DBT, and that seemed super straightforward. But once we did that, we found out that we are actually running out of memory, and so that was mostly caused by the fact that like um, uh, the date spine that we were using for all of the metrics when we do rolling metrics caused a bunch of basically unnecessary data, but that loaded up everything in memory. Yeah, it went from like you know for any given point in time, or like I think for 50 gigabytes, it turned it into multiple terabytes, which is what killed the BigQuery job at some point. And so part of my solution to figuring that out was actually running this with SQL Mesh by doing a rolling window on a daily interval. And then we did the simultaneous thing where we were like, oh, we're going to run this in ClickHouse as well. So those two things paired together ended up being like a marriage made in hell. So yeah, sadly, um, it was
In this
ClickHouse didn't
diagram,
like. Mhm.
sorry, in this diagram, the metrics worker cluster, is that Dask based?
Yes, yes, it's a dask
And
based thing. Yeah.
and this TrinoDB, so you're no longer using the DuckDB as the uh
Oh no, we
com-
are. Sorry,
oh, we
we
are.
are. Yeah, yeah. So that is later on down here. So download exported tables to a local DuckDB. So the reason why, yeah, yeah. So I maybe the background. We kind of all have the background, so I guess you can read it here. But basically, like, so to go over this, the general, the general way of doing this. So this first non-metrics flow is just what normally happens with SQL Mesh. Sorry, I'm trying to zoom in, and it's like doing weird things when I click. Um, and okay, that's better. And then this metrics flow is what happens when you have a metrics model. So from SQL Mesh, this first line here, you get you send the query to the metrics worker, or sorry, the metrics front end, which is a service that interacts with these workers to actually uh, like make all of this happen. And then what that does is it exports the data from Trino, um, ex puts that into a Parquet file inside GCS, and then we use that at some point here to download
Why?
those into DuckDB. And
Where is the code for the front end, and why do we need a front end service as opposed to just like doing
running
it?
it,
Yeah.
yeah. So yeah. So this is one of those things that kind of found doing this with SQL Mesh. So SQL Mesh, when you run SQL Mesh, it will start a bunch of threads, and then it'll just do a bunch of stuff. But we don't have a lot of control about how like all of the scheduling for that thread happens. So I don't actually want any of the management the um, of the Dask cluster to be inside SQL Mesh. I'd rather just SQL Mesh call a service and then get the result, right? Because that just was a bit cleaner than having to figure out how I would also do that while also managing all the SQL Mesh related stuff. Uh, so SQL Mesh, it basically runs as it usually does, and we don't have to touch many or any of the internals there, just because that would be a much cleaner separation.
So this is just to
So
be able to
that
manage the. This is to be able to manage like work queues or job queues and things like that.
exactly,
And
exactly. It's basically a very simple job queue. Mhm.
what does
Yeah.
SQL Mesh give you at this point? Because like in theory,
So,
like, originally we were thinking of doing these as like Dagster multi assets, right? Which would give you a lot more control
mhm.
over these things, right?
Yeah. So the thing that SQL Mesh gives you is really the management of all the dependencies of everything inside of all of these models. So we can actually mix the metrics models with non-metrics models. So you can actually derive things from those, all of that. So basically, all of the DBT-like workflow can still work, and then you can add all the metrics models in and then do downstream of that also dbt like workflows, and then all of the connections to those things are all maintained by SQL Mesh. So it
Got it.
would be like if we were to do this with Dagster, we would have to write a lot of that stuff on our own. That's kind
Yeah,
of
fair enough.
yeah.
Okay.
So yeah. um and it also already does some of the yeah, like a lot of the things with Trino, like managing the iceberg, or like the specific model like increments. Though it'll do all those things. So
And you're
um
running Trino in a Dask cluster?
no, so Trino runs in its own cluster. Yeah, so there are a lot
So
of
what is
clusters here.
that used
So
for?
there's yeah. So Trino runs in its own cluster when it needs to compute Trino things. So Trino things being anything on our Iceberg data lake. And then the reason why the Dask cluster exists is because Trino has no way of like you can't pre-warm the cache with Trino. You can't you can't do a lot of those the things that we actually need this to be able to do specific for our specific purpose, because what we're trying to do, at least for a backfill, and maybe even into the future, right? Like but for a backfill, what you need in order to actually get it done in a fast enough time with Trino is to load all of the dependent tables into DuckDB and then just calculate on that really quickly, or load it into cache, basically. I attempted to set all of the Trino settings that would do something like that, but there's no way to trigger a pre-warmed cache. So as you're doing it, you're basically trying to run cache, and the way that these rolling windows work, you basically get one cache per day just because of the way like it runs
When
for
you
every day
say
in the backfill. Yeah.
when you say cache, currently you mean DuckDB, right?
Yes, I do mean DuckDB, but
And
sorry,
so
when you use Trino, you can also it'll also cache any dependent tables. for the given queries you have. So if for whatever reason you had very hot tables, it would be able to, the next time you make a query, it would have those in memory, or it would have those in disk on the local Trino. Yeah.
Um, so is it a fair simplification to say that the DAS cluster right now is used mostly for partitioned DuckDB and Trino has its own separate cluster?
Correct. That is, yeah, exactly.
And is it fair to say that the Dask DuckDB cluster is currently only used for calculating these rolling window metrics, whereas Trino would be used for every other model?
Everything else. Yes. Yeah. And even the normal metrics models. So really I mean, we can use this for the non-rolling models, but I don't really see a point. You could use Trino to do it and it'll do it just as fast. So,
How do
yeah.
you specify which cluster to run which model on?
Yeah, so that is all done at the very instantiation of SQL Mesh when it starts loading the factory. So it will, when you load the factory, and this is actually describing the issues, actually, which is a good thing. But when you load the factory, or at least how we should be doing this, um, uh, you can actually get from SQL Mesh, it'll tell you what the current engine is. So like,
Could you show us an example?
is it DuckDB? Yeah.
Awesome. Sorry if I'm asking a lot of tailored questions.
No,
Happy.
this is deep. This is deep.
Yeah,
Yeah.
feel free to jump in if you have questions as
Um,
well. Sure.
oh, sorry. It's not in this one. It is here. Yeah, this needs to. Yeah, so this is the thing that actually runs the model generation. And so from here, you'd be able to understand whether or not, like, what's the current dialect being used. Um, you know, you'd also get additional information about, like, what are the defaults for SQL Mesh as it is currently running. So we should, in theory, be able to use the information here to then generate a different kind of model. So depending on, so the reason, yeah, so the way that we would choose to do this is based on this specific, like this instantiation of a
Could,
model.
could you
This
show us
model
an
class is
instantiation?
used. Yes. Give me a second. Yeah. So what happens here is, yeah. So what we do is we read through. Actually, let me open up a different file as well. We read through a file inside metrics mesh that looks at the OSO metrics. Oops. Models. And what it does is it'll interpret these as, so it'll parse through this like factory function of these metrics queries and turn these into generated models. So these generated models will be using different dimensions, like this windows here are 30, 60, 90 days. And then it'll pass in these variables to those things, and it'll use this specific SQL as a template for doing the generative model
I see. So
creation.
this metric query def implicitly uses the DAS cluster under the hood, right? And
Yes, it will. Yes,
there's some other way to instantiate the Trino cluster.
correct. Yes. So Dask, yeah, sorry, the Trino cluster is instantiated as just part of our like our Kubernetes deployment. So there is no, it is not, it is just on. Like a very like one node is just on right now.
And is Iceberg always the source of truth? Like things are always reading and writing back into
Yes.
Iceberg?
Correct. So the only time where that is not the case, if you look here, is God. I just let's see. There's no good way to zoom in this bad boy. So the only way to do that is so the only time that is not the case is when the metrics worker cluster is exporting all of the calculated metrics. It should write directly to GCS cloud storage here. So it's this last line. So this one right here is the metrics worker. This is the cloud storage, but we upload everything directly to GCS. And then what Trino will do at some point eventually here is it'll trigger a query to import all of those Parquet files into an Iceberg table. So then it'll remanage all of that data, and then we'll just clean all of that up.
So the Dask cluster
that
is writing to GCS, but Trino has
correct.
a query to manually import from GCS.
Correct. Yeah, that is the fastest way I've determined that this is actually going to work. It goes from multiple hours to hopefully within seconds, but at the current test of like a 6 node system, we're at like 5 minutes.
Cool. And how much of our data pipeline is going to be encompassed by this diagram? Like, is this still everything downstream from events, or
this is currently everything downstream of events, but there is nothing preventing everything else from running in this non-metrics models, except for the fact that all of the we would have to reconfigure Trino to read from BigQuery to get the current backlog of BigQuery stuff, like GitHub and all of the blockchain stuff. But then once we do that, as long as it has the correct mapping, and we have rewritten. The other big piece is rewriting the DBT things into SQL Mesh so it can go in this. Then this would encompass all of that. So those are the two big pieces of. Those are the two big issues that would need to be done in order to make this all one giant contiguous thing.
So how is data imported now if you don't have the BigQuery connector set up for Trino?
So the data, the way the data is imported now is, I guess that is actually a missing issue. So the way that I have imported data is also in the same way that we do cloud, like BQ to ClickHouse. I basically write to the write parquets, and then I can read parquets from GCS like fairly immediately. So
okay,
that's the current model.
So we have Dagster assets that load in and out.
Not yet. Yeah, that is a to do. So.
Oh, but it's manual right now.
Yes, it is manual right now. Yes, but it does work.
How do you see these worlds being married in the future? Like, people have already complained about like how terrible our documentation
complexity.
is.
Yes.
This like, as far as I'm aware, SQL Mesh doesn't have the same DBT docs generation facility, right?
It does and it doesn't. It's different. So they do have the SQL Mesh UI. I don't think I can show it in this current computer right now because my current SQL Mesh thing is a little. The local one is broken.
Right. It's more of like a SQL console.
But they have a SQL console, but they also include for each of the models. Each of the models gets documentation automatically. You get all of the column lineage also for all of those. So I believe you can have a read-only version of that, so that it's not the SQL Mesh console. Yeah. So I'm fairly certain that exists as an option. I mean, I can double check, but that would be the way to marry that, as far as I'm aware. If not, like you can also define things using the DBT method, and you could just write DBT docs that way. Like you can still define those YAML files, and you just use the DBT CLI if you really really wanted to. But I don't think that is the. I
SQL
don't
Mesh,
think that's the right feature that would make things. Yeah.
does SQL Mesh have a native way
we-
to specify like human readable descriptions and stuff?
Um. Uh. So the native way to do it is to document inline. So they actually parse because of the way that SQL Mesh can parse, is aware of it has an AST for SQL, so it can take the abstract syntax tree and actually figure out where
Like
things
JS,
are supposed to.
like JS doc style comments, or how is that done?
Yes, they're basically like JS style comments, I think. Actually, no, wait, don't quote me on that. Yeah, I'm not 100% certain, but I know that
There is some way.
at the very least, yeah, at the very least, there is some way, and it is in line with the sequel.
And okay, cool, fair enough. So how much of this is already implemented versus still needs to be implemented?
Yeah. Okay. So things that are implemented. Partially, this front end API is implemented. I need to do some rewrite there. This metrics worker cluster is implemented. The reason why the front end API needs to be re-implemented a little bit is I wrote it as an arrow flight API, which I thought is what would have worked really well, but turns out that actually will make things very slow when using SQL Mesh to write things back into Trino, which is why I came up with this thing. This part at the bottom needs to be written. And then all of this is fine. I hope you can see my mouse.
The metrics front end is only for the Dask cluster, right? Like SQL Mesh handles
Yep.
Trino directly, what I can tell from this diagram.
Correct. Exactly. That's exactly correct. Yes. That is 100% correct. So the SQL Mesh will interact with the metrics front end API, but it's really just a call to it's a very simple call, and it should basically hit that API and then pull the API for is this job that I submitted done, basically. So
Cool.
very, very simple.
Javi, Carl, did you have
I know this is a lot.
Well, it's a lot of info. I think that I will get more advantage in a one-to-one call. I think that this definitely needs me to take some notes. I think it's really complex, and I can see what it's trying to achieve. So yeah, it looks good, Ruben.
Yeah, it's complex. It's complex. I won't say otherwise, but this is I can assure you that this is has gone through like quite the ringer of exploration at this point. So yeah.
And you did do
Cool.
some exploration of running the SQL. I vaguely recall you said like last sprint or the sprint before, you tried running the SQL Mesh metrics factory on top of Trino directly, but the caching there wasn't fast enough or something.
Exactly. It just wasn't fast enough. It basically was operating at like nearly the same speed as what I had seen in previous iterations, maybe a little bit faster, but like the time to completion would have been measured in days. So yeah. Like and then there were some other write errors and things like that. But once I fixed those, it actually made the time to completion even longer. So yeah, it's definitely measured in days if we did it that way. Yeah.
But it would be simpler at least. Like you wouldn't need the Dask cluster and the metrics.
Correct. Yeah, that was why I tried it first, because it was significantly simpler, but just didn't work, sadly. So, yeah.
And that's because, like, do you have like a one-liner for what was the blocker there?
Oh yeah, the blocker was that the caching would not pre-warm like all history. So what would happen is that because of the way that the rolling metrics worked, and I tried to do different ways of doing this, but also because it's distributed, it it basically the cache wouldn't warm evenly across the cluster. So and then on top of that, unless you are trying to uh, get a query that gets all rows, it will only cache like either a specific column or something like that. So the cache didn't have exactly what I needed in it. When if I were to write like smaller queries to try and basically trick the system into pre warming the cache. So
Well,
Trino
you don't have
Trino
like
cache.
what is the Trino cache? Is it just like a simple LRU or something?
I think so. It's called Aluxio. Apparently, they did a bunch of work in it. I didn't look too much further into it after it basically, yeah. It took quite a bit of hours, like to try and go back and forth with it. So at that point, I had sort of I'd already seen the DuckDB thing working, so that's why I continued down that path. But
Um,
if it is something that we want to explore, I can double
well,
check.
like I think the way that the way that you're describing cache is fundamentally different between Trino and DuckDB, right? Like the reason why
Correct.
the reason why Trino is slow is because it doesn't have awareness of your workload ahead of time. So at runtime, as you're
Correct.
doing, it's like caching columns as you do queries, and
Correct.
in the default
Yes.
case, it is extending into Iceberg to fetch individual things, which is relatively slow, right?
Hmm.
And the way
Yes.
that you're using
Exactly.
DuckDB is you're quote unquote pre-warming it, but in reality, what that means is you're basically putting everything in memory ahead of time,
Hmm.
and then
Hmm.
you're good, right? Um,
Yes.
like I know Trino has a memory connector, right, which basically allows you to store all data in RAM. Like, did you
Hmm.
try the memory connector?
I did not try the memory connector.
Well,
Um.
it's basically to say that like you can have Trino processes that run, and you forcibly create tables like in memory, where like an entire table can exist in memory, which would be very similar to what you're doing right now in DuckDB.
Yeah.
Um, anyway,
Um.
not trying to make your life
Yeah.
more
Yeah. Yeah. Yeah.
complicated, but it's.
No, 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 no. Yeah, I can take a look at that. Double check. The one issue that I have with that is, and the reason why the things became complicated with all of this is that when as SQL Mesh is processing everything, like if you are dependent on a table, that is being calculated or that had just been calculated, like sending that data back out to all of the additional, like let's say you wanted to run this like in memory thing, because I was trying to get it from the file system direct on each of the servers as well, and there, yeah, but then you would have to run an additional process inside of like the pods to do something like that, and then you'd have to figure out a way to coordinate those as well. So it ended up feeling very similar to what I was already doing with DuckDB. But yeah,
Yeah,
that
it might
is
actually be
interesting.
identical. Like, I think if you were to actually go down this memory connector pathway, like, can you have multiple connectors in a single Trino cluster, or would it be a separate Trino cluster?
You can have multiple connectors, yeah, and that's actually how we do the. That's how we do the Hive. We have a Hive connector, which is what loads from GCS, and then there's the what do you call? Then there's also the Iceberg connector. So, and then you can have multiple instantiations of each connector. Yeah.
Oh, I see. Um,
Hmm.
but I think it might give you less control over what you're doing, because in the DuckDB world, you are partitioning, and then each DuckDB instance has a different partition, right?
Not currently partitioning, but that would be the next goal would be to do it that way. So that way it's even I could distribute even better. But for right now, the simplest thing was just to download everything really fast. So yeah, which
Oh,
still
okay.
works
So the-
because it all fits on disk right now. So
Got
yeah.
it. So DuckDB is a full replica of everything,
Mhm.
but it's small enough that
Exactly.
it could sit on a single disk. Got it.
Mhm.
Yeah. Sorry, I'm not suggesting you change anything. I think in reality,
No.
memory
These are good questions.
could be sufficient. Like, I'm not sure if it's sufficiently flexible to do what you want it to do, because it might actually just be like simple in-memory tables that
Yeah.
are across all clusters, and then across the entire cluster, and then you can actually, partition and do interesting things. So
Yeah,
cool.
I'm not entirely sure. But yeah, I mean, I think if for whatever reason SQL Mesh like ended up supporting Star Rocks tomorrow, I think Star Rocks can actually have a very targeted pre-warmed cache. Yeah, obviously I haven't tested that because it's not available to me right now. So yeah.
Cool.
That-
Fun times.
Sorry, yeah, that was a lot. I apologize. I thought, yeah. But yeah, this is everything's notated as best as I can right now. I will probably I will add more issues specifically around some of the things we talked about today. So yeah.
Cool.
Cool.
Thanks.
That's all I got.
Awesome. Well, in that case, I'll show my work with the npm downloads that I've been doing through the past week. Okay, can you guys see this? Hello?
Yep, we can see.
Any confirmation? Awesome,
Yep.
perfect. Well, so one of the things I was working on was this Daxter asset that fetches all downloads. So how does this work? So basically we get all of the artifact names that we have now in Artifacts v1. Currently it's around like 65 of the top packages. And then we get all the npm download statistics. So this is pretty simple. What it does is it fetches the data in the range. It checks that we haven't reached the error. Basically, npm has some flaky error handling. And when it's like a super old date for a package, it throws like this error. So we're omitting that. And then we go day by day. We sum the dates. And then if we are missing any of the days, we just say, hey, we're missing some data. So basically, this gives us some data like this, which has the package name, it has the downloads for that period, and the date. And with that, we can do some cool metrics, such as this. So basically, for example, here we can have a list with all the top packages by downloads. For example, we can see that Safe Global SDK has like almost 2 million. Well, to the power of 7. And then we can also see that these are like the monthly downloads of the top packages, and we can like see them side by side. And the cool one that I really like is this one, which is the monthly downloads of top packages over all time. So we can see all the trends. This is just for the npm packages, but we want to like fetch this for Cargo, for PyPy, for Go, and have a list of all these packages and dependencies that I'm tracking over time. This is a really interesting metric. It will unveil a lot of new metrics. So yeah, I'm really excited to land this on the other ecosystems.
Sweet. Quick question, Javi. For this to work, it has to be a library that is in OSS directory, right?
So yes, what I'm doing for the moment is I'm fetching the ones at the Artifacts v1 Mart. I had this conversation with Ray in Bangkok, and we decided to follow this approach for the future, for now. Because in the future we will add more artifacts from different sources, and if we have them in like this space, for example, it will be better.
Okay. But things that are in the SBOMs don't get indexed unless they're in OSS directory.
Yeah,
I was suggesting that not, because is there any use case where we will need that, Carl? Because my understanding is that if it's registered, it'll be an OSS directory, and those are the only things that we're going to be rewarding impact on anyway.
Yeah, exactly. I think that's fine. I've just noticed that OSS directory probably gets stale as people have new packages and so on. But we can deal with that later.
Yeah, but the way to solve that is with a direct connection to OP Atlas, not if it's not registered in OP Atlas, you're not going to get rewarded anyway, right?
Yep. Yeah, for Optimism, it's totally fine.
I see. Yeah, for other ecosystems, fair enough.
Yeah.
Um,
And I think in the future
yeah.
there might be some like discovery that happens, but for now this is totally fine. I'm just asking.
Yep. That makes sense. Javi, I have another question for you, which is you've written a number of these connectors now. You're an expert in DLT at this point, I'm sure. Another thing that we're going to need in the not too distant future is the DeFi Llama TVL APIs are all also REST APIs that are probably not OpenAPI compliant.
Yep.
I'm curious, like, given your experience of writing so many of these connectors now, how do you think about like what is the best, like lowest engineering cost way to do this into the future? Is it like continue like if you had to do another one, would you just write another DLT connector like you did for this, or like is there a generic factory we could make that could actually make your life easier?
Okay, so this is a really good question, right? The thing is that for how I see it now is that the engineering cost of doing one of these is pretty low. And the thing is that it stacks over time. So if I'm going to have to write 50 of them, I may as well invest my time into writing a generic, as you said. The thing is that there are quite some, REST APIs are not standardized. They basically do what they want. Some of them follow the OpenAPI spec. Some of them are GraphQLs. Some of them, So for like this, so one of the cool things that caught my eye is one of these PyPy packages that we use, which is GitHub. So basically they have like this, all of this package is auto-generated code. They parse GitHub's OpenAPI spec and they generate all of the metrics, all of the routes, all of the documentation, which is pretty cool. In the end, how I see the future is us having one of these generic DLT connectors that basically has some sort of, how do you say, like a meta language that we use to like describe the routes, what to expect in each route, and to like generate the Pydantic models on the fly. The engineering cost of this is, I wouldn't say elevated, but it needs some consideration because in the end, a lot of things can change. But I think that if we start to write one of these in the future, contributions will be us with this asset that we have, like the BigQuery to ClickHouse, which is literally a 5-line config, as Ruben did. So yeah, I think that we should start to invest into this.
Yeah, I think that GraphQL one, like I think we do need to treat GraphQL as a separate like special case, which I think you're already very close to creating a generic factory for that, or at least that's what it sounded like last time we spoke about it. One that's more difficult is like generic REST APIs, but I think like I don't think we have to solve like if we factor GraphQL out and think about REST APIs separately from that, I think there probably is like a default path that's probably sufficient. So let's assume that outputs are always in JSON and not some other format like XML or something like that, right? So we can make some assumptions like we're only getting JSON back. Then the only thing that we need to worry about is finding a way to enumerate the APIs and the possible parameters for, say, GET requests. And using the OpenAPI spec is probably a reasonable approach there. But I would agree that generic factory, I'm going to guess, is going to be, tell me if you disagree, probably take longer than the generic GraphQL factory. Is that right?
That is correct, yeah. As you recall correctly, the GraphQL generic asset factory is almost implemented. I'd say that it is a 1-pointer, 2-pointer now. It's almost finished, like in that branch. So I think that that's something I can ship really, really easily without any doubt. The one that I need to put more thought into is this REST API. I will have to create this parser for the OpenAPI spec. I will have to like handle the cases where that spec isn't there, so that takes more time.
Okay, yeah, not anything we need to worry about immediately. But by the time we do another on-chain round, we probably will want to start getting some more DeFi Llama data. So just something to be aware of.
Yep, indeed.
Cool. Thanks for sharing.
Thank you.
All right, let's pick him up. I guess I have lots of lightning demos right now. Can you see my screen?
Yep, you're good.
Yep.
All right, so first up, we've been wanting to do this for a while, but we recently came across this package which makes it very easy to do synthetic controls and basically take any metric that we have in OSO and set up a cohort and then compare it to a synthetic compare it to a counterfactual using a synthetic control method. So this blog post explains a bit about the thinking behind it, and then it shows some examples of how to grab a set of time series metrics and then plug them into the PySyncon package to basically come up with a model. So here's like a very simple implementation. It kind of does a training set over the past 2 years. It tries to fit that to the last year of data. The metric that we use is the active developers over 90 days. I hid the names of the ecosystems that we benchmark this against just because it's a public post and some of them might not want to know that we're using them as the counterfactual. In any case, and then a few predictors as well, which we can also tweak as we have more metrics in here. And the result is a nice graph that basically shows the difference of the treatment group, which is the cohort of Optimism Red 2 PGF3 projects relative to a counterfactual, a synthetic control. That's our counterfactual. So you can read more about that here. The notebook is also linked. So if you want to come in and play around with your own versions of this, again, here's the request to get the time series metrics, which right now we can only get out of ClickHouse. And then you can, kind of set your parameters over here. You can identify different dates that are relevant, and then you can generate a graph over here. You can also do this for transaction data. This is a simulation using Grow the Pi transaction data. And yeah, that's basically it. Any questions about this?
The fact that this is wired up to ClickHouse probably means that, like, aside from the people in this team, no one can actually do this, right?
Yeah. Yep. For the time being, until we move things back into BigQuery.
Yeah, I mean that was another question that I had for Ruben, which is like, this is probably a one-pointer, but it probably makes sense to have every model just re-exported back somewhere into BigQuery strictly for things like this, so that we can easily do a query in Colab or Jupyter and right.
Would we only want it to be the marks or everything?
Definitely the marts. Open question for everything else. I think, like, for model development, I don't know, tell me if you agree or if this is helpful or not helpful, Carl, but is it useful to be able to run queries in BigQuery as you're like testing and, you know, developing new models? I would assume so.
Yeah, I definitely do that a lot. But I think for the average user, just having the MART models will be all that's necessary.
Yeah. I would say, like, the MART models
Cool.
probably, like, are good enough for 90% of use cases, and then for the 10% of use cases where people are actually trying to contribute to the intermediate models, like,
Yep.
it helps as like a place to test and debug.
Yeah, I mean, I would hope that we have a different way of dealing with that. You know, something like around DuckDB or something like that. As assuming that we're moving to, you know, SQL Mesh in more places, because then, yeah, that is 100% possible to do, right? But yeah, I mean, I guess BigQuery could also be that place, but with DuckDB, you don't have any of the cost concerns.
Fair enough.
Unless yeah, you're trying to get exactly real data, then yeah, that's a different story.
Well, there's probably two cases. One is you're saying, like, throw a subset of data into a playground data set in DuckDB
Mhm.
where you can
Mhm.
test and run things locally, right?
Mhm.
So
Yes.
that definitely makes sense. And then the second of which is in testing and CI/CD. We probably want some way to measure drift,
Yes.
which
Yeah.
is something that like the Recce guys have been trying to help with.
Mhm.
Yep.
Which is probably a separate setup for something like that, right?
Yeah. Yeah.
Um, but I think what you're saying is that in the future, we'll probably continue to maintain public BigQuery datasets for source data, but for anything in the production and playground pipeline, it might be easier to share it directly through GCS or something like that. Is that what you're saying? Like for DuckDB?
Yeah. 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 That is kind of what I'm saying. Yeah. Yeah. Exactly. Yeah.
Um,
Because you could also share like DuckDB doesn't have like great support for Iceberg yet, but it does have support for Iceberg, so it is a possibility to just read directly from
is our
GCS.
Iceberg publicly readable?
It can be.
I thought you were worried about costs for that.
If we do that, we should do requester pays, and that's it. Yeah, and
Fair
then the
enough.
metadata we can publish the metadata links for each table, so you don't have to use the metastore.
Oh, cool.
Yeah.
Um, whatever the answer is, we need some answer for things like this. I think that's all I'm saying.
Totally. Yeah. Sorry. Yeah. No. Sorry to complicate things. I was just kind of taking off the cuff.
Yeah, no, I trust your judgment in terms of how to best do this. I just flagging that we don't have a good answer right now.
Cool.
Sweet. Moving along. Got a few more here. We were at DevCon last week. I gave a presentation that included the use of synthetic controls and talked about a lot of other things. There's you can see the presentation on YouTube. There's also a version that has the speaker notes and everything in case you're interested, which I can share. I think there's a lot of good stuff in here. Probably one of the most useful parts is debunking some of the myths that have come up around retrofunding. There's the insights that we shared over here. Some good data viz on the domains that have been funded and the different category split, and then some of the challenges that lie ahead. So you can check that out. Again, it's there's a video of it, and you can also get the raw presentation as well. Let's see. Next up, we have been making some updates to OSS directory. And one feature that we've had for a while, but we haven't actually demoed, is what I call the TOML adder, which basically allows you to take a Electric Capital crypto ecosystems TOML file and very quickly bulk update OSS directory so that any projects that already exist are added to a collection and any new projects are automatically created. So I'll give a demonstration of this. We can pick an ecosystem. I think actually, why don't we just do base? Because that one we already have a lot of the projects for. I'm just going to run this. There's a little command line script, which I'll run over here. I think first it prompts you to, there's a few kind of.
You're not
Oh,
sharing your
sorry.
screen, by the way.
Let me change the. All right.
I'm assuming it idempotently updates project files as well, right?
Yep, it does. Let me just do it again. Sorry. Okay. Can you see this now? Can you see the command line? Hello?
It took a second, but I see it now.
Okay, great. So yeah, it's just a command line script. And you can basically, there's two ways you can do this. One is that you can literally review every edition one by one. I'm going to ignore that case. It also takes a snapshot of the latest version of ecosystems, the crypto ecosystems directory. I just clone it and have that locally and pass that as a variable in my environment. So I'm just going to use that. It will also take a snapshot of that. So I'm going to take the most recent snapshot. The ecosystem that we care about is Base. So I'm just going to type that in. It is case sensitive. I do take these kind of regular snapshots of OSS directory. And so I'm going to take a new snapshot right now. Right now, there's 4,226 project files that we have in OSS directory. And that includes over 5,000 GitHub URLs. And so now I'm going to process the ecosystem as a new collection, as opposed to adding to an existing one. And there we go. It basically went through, and we'll now have a file called base.yaml in the collections. Let me see. We have a lot of base.yamls. Let me just find it here. Oh, sorry. I need to create the collection. I haven't done that yet. So yes, we will create a collection for Base. Let's call it Base Crypto Ecosystems. We'll give it a name. Okay, so I did it. And you can see that we actually had a lot of the products already. So it only added 10 or so new ones. And then here's the file that it created, which has about 120 projects in it. And so if we wanted to, we can just commit this and it will automatically, update things.
Cool. Awesome.
Yeah,
This is this is a script that you've been iterating on for some time now, right?
I created it back in January and I've done it a few times since then, but it's quite helpful.
Cool.
Yeah, and it grabs all the information and populates it in a file like this. So that's it. And last week I added, let's see, we did 3 or 4 new ones, some big ones. So we had all of Ethereum. We did some more Polygon, Arbitrum, Optimism updates, added Scroll, a whole bunch of new projects were added. So we're well over 4,000 products now in OSS directory. And
we
I
are
think,
like,
what's that?
oh, I don't know if you had more to share here. We are at like 5 minutes to the hour, but I know last time you wanted to give a quick update on RF5, RF6 stuff. Which
Yeah.
we have time for.
Let me share
Do
this
you want to do that this time, or?
Yeah, I'll do them quickly. So first off, we have another blog post all about Retro Funding 5. This came out, I guess, 2 or 3 weeks ago at this point. It's a very long post. There's a lot of data viz and analysis in here. The main issue with round 5 was that the distribution was really, really flat. So here's like the distribution curve. If you compare that to round 4, which used metrics, it was a much steeper curve. Even round 3, which was also project-based voting, had a steeper curve. So this is really the flattest distribution that Optimism had ever seen. And it definitely created some problems. Partly this was because this is how voters voted. So they really preferred to give something to everyone. You can see all of the different curves that individual voters did in this big graphic here. And for the most part, they were pretty flat or not very steep. And there's a difference that you can look at between experts and non-experts. So experts did tend to have a steeper distribution, more of a power law, and they also tended to debate a lot more how much a top project should receive. You can see some of the differences in this graphic over here. There's more statistical analysis on this, a lot of data viz. Yeah, you can see like the individual distributions. Each one of these dots here represents a vote. And yeah, there's a lot here. I won't go into it. It's a long blog post. We also did a post on the Optimism forum, kind of discussing some of the implications and how that should ideally be rectified in future rounds for 2025. but you can read all about that in the blog post and the links. And then the last thing I will show, my goodness, it's all optimism stuff. But this is it's still loading actually. But it's basically a retrofunding dashboard, which allows you to look at projects as they come in based on the attestations. So sorry, it's loading. I tried to run it right now, but there's, I think, a lot of data that came in over the past couple of weeks. But you can see that here's the applications by round. This graphic over here shows like the daily amounts that are coming in by round 4, 5, 6. You can see it cumulatively. Yeah, this is the refresh button. Over here, we can see different types of entities that have been registered. So you have organizations, and then each organization can have one or more projects. This also looks up whether the projects are on-chain or if they have open source repos. This kind of looks at how old the repos are and how many stars they have. I think those are the heuristics that we've used. And you can get like a table which shows all of the projects in the database. You can see, growth over time and signing up organizations. The other cool thing, this is definitely something that I use a lot, is just a way of taking any retrofunding schema and basically getting a static snapshot of all of the data. This also kind of pulls the data from IPFS. So here's the 7 or so relevant retrofunding attestations that are being used. Once you get the data from OP Atlas, I think most of that will also be available from there. But here's the raw attestations if anybody wants them. So that's it. Yeah. Any questions?
Any do you know when Jonas plans on shipping the announcements for the next set of rounds? And is there anything we can do to help with the community discussions?
It's happening this week. I was on a call yesterday where they socialized some of the ideas to an intergroup of citizens. More will be coming soon.
Exciting times.
All right. Well, that was a jam-packed session, as it turned out.
Yeah.
All right. Well, thanks everyone for tuning in. We'll see you in 2 weeks.